At this part itself, we do mill testing because, as mentioned earlier, the earlier you get the errors, the better it is for you, the less cost and less time. Once the model is made, you have to check whether the model made is as per the requirements or not. So you have to write the test cases, or you can use BTC where you can do the requirement based testing. You can import the test cases. In some cases, if you're doing back to back, you can generate the test cases, and then the model, once it is fixed that it is as per the requirements, you can say, okay, the model is fine. And if there are some changes, you do the continuous changes. So at this step itself, the development team fixes the model. So the time is saved, cost is saved. So this is a very important point. BTC helps us a lot of times, and this ensures software quality. So most of the bugs are eliminated in this first step. Next, we go to the code generation. Once you make sure that the model is correct, you generate auto code out of it, because once you have invested so much time in model based development, it is easier to generate code than to write manual coding. There are some people who still do manual coding out of a model, but I personally don't see a very good use of it, because now dspace, which is very much easily integratable with Simulink and even MathWorks embedded coder, they can easily generate code out of the model, which takes less time. Yes, you have to give some cost for the license, but I think that is more advantageous instead of writing manual code out of a model, especially when we see models like autonomous emergency braking or steering assist system, which has so many subsystems, so many depth of subsystems. It's almost like 10,000, 12,000, 15,000. I'm just saying the minimum 15,000 lines of code. It's very difficult to write manual code. So I would suggest you to do auto coding. Moving to the next, we do unit testing on the code level. So again, we take help of BTC, which is a wonderful tool, as I mentioned. We use the same requirements which we use for mill, and we run the same test cases which we ran for mill, and we run it on the SIL level. Now BTC also provides a debugging environment on Visual Studio. You can take the debug environment out from the PC, which has the system which has the embedded tester license, and you can run it in your system as well. So in Visual Studio, you give the inputs and you get the outputs, right? And if the mill outputs and the SIL outputs are correct, then you can make sure that the model and code are at the same level. There could be chances that, as mentioned by some of the speakers, that the code is optimized, or there could be some bugs as such that the model and code were different. The code was not generated as we wanted. So those things are covered here. So here we make sure that the code is correct, because this is the most important step, I would believe, because code is the final output. We don't flash the models into the ECU, we flash the code into the ECU. And since BTC is ISO 26262 certified for testing, after this SIL testing, we can guarantee that our testing has been ISO 26262 certified. So this is also a plus point. It can also identify the issues, and obviously the software can run on different operating systems. MATLAB Simulink models runs on Simulink and other things, but we can ensure that the software runs on different operating system processes without any compatibility issues.